Given that the two lines intersect, find a position factor of intersection. So from the first line, this is actually 1 to 1 from here, and a2 minus 1 times lambda. For the second line, we have 2 1 minus 1 and 2 minus 1 1. So just use column factor notations. So since they intersect, at the point of intersection, the point satisfies both equations, so we just equate them and we analyze each component. For the x component, we have here actually we are using not the first x component because we have a here. Okay, so we're gonna need to use the y. 2 plus 2 lambda equals 1 minus mu, and the z component 1 minus lambda equals minus 1 plus mu. Okay, so we use the y and the z component, we can find the lambda and mu. After we find lambda and mu, then we can find a. So here we can just add both equations. We can just eliminate the mu and also the 1 actually. So we add, we get 3, add, we get 1, add, we get 0, so lambda must be minus 3. After we find lambda, we can plug in to one of the equations. Using the second equation, replace lambda with minus 3. This is 4, so mu is 5. Okay, so after we find lambda and mu, we can plug into the third equation using the x component. 1 plus a times lambda equals 2 plus 2 mu, but we already know that the lambda is minus 3 and the mu is 5. We can find a. So we can just simplify. Here we get 12, subtract 1 from both sides, divide both sides by minus 3, we get the value of a. After we find the value of a, to find the intersection point, just replace the a with minus 11 over 3 and replace the lambda with minus 3, replace the mu with 5. We can use this line equation and we're gonna get this, or we can use the other line equation, we're gonna get exactly the same thing. Alright, next part. Acute angle between the directions of the two lines is cos inverse 1 over 6. Find the two possible values. So between the two lines, previously we have the two line equations, and because we're looking for the angle, we need to use the direction factors, the ones with the parameters, the one with the lambda and mu. Okay, so these are the direction factors, these are the position factors, or basically a point on the line. Okay, we are using the direction factors. This is the MF19 factor formula. We are using the dot product rule. So if you rearrange, cos theta equals a dot b divided by magnitude a magnitude b. So in this case, the a and the b are the direction factors. And the cos theta equals dot product divided by the product of the magnitudes. To find the dot product, if you use this formula here, we multiply corresponding components and then we add. So a times 2, 2 times minus 1, and minus 1 times 1. For the magnitudes, we use the square root of the sum of the square of each component. So a squared, 2 squared, minus 1 squared, add everything. Same thing for the other magnitude. And from here, we simplify. So this is 2a, this is minus 2, this is minus 2 minus 1, so we get minus 3. And from here we get 4 plus 1, which is 5, so a squared plus 5. And from here we get 4 1 1, so that is root 6. And then we are solving for a here, so we can just cross multiply. So 1 times this guy, that's what we get, and 6 times this guy, we have this, and then we square both sides, so we lose the square roots and we have to square the right hand side here. So 6 times a squared, 6a squared, 5 times 6, 30, and After we square this, so again the process is to square both sides. We cancel out the square roots on the left. So when we square this, we get 144a squared minus 2 times 12a times minus 18, which is this. Use your calculator. And minus 18 squared is plus 324. So now we subtract 6a squared plus 30 from both sides. So 144 minus 6 and 324 minus 30. Now we have a quadratic in A. So we use the MF19 quadratic formula. Identify the A and the B and the C. Plug into the formula. Use a calculator. We get the two possible values of A. Right, that's it. I'll see you again next time.